Audio Jungle.
Assalamu alaikum, my dear students. How are you? I hope all you are well by the grace of Almighty Allah. I am really missing you and our lovely school campus, Milestone School and College very much. Let us pray together to get back our campus. I hope you will understand the lesson of this class and your good comments on the video gives us the inspiration, my dear. My dear students of class 6, today our chapter number 6, name basic concepts of geometry. At first I will discuss some basic things and then I will solve theorem number 2 and the last one very important problem from the exercise, that is problem number 4. It is also very important for the examination. Review of previous lesson. My dear students, in the last class you have solved some problems from exercise 4.3. Now I am going to give you one problem. Please start for solving. You have 2 minutes time. That if x equals to 5a plus 7b plus 9c, y equals to b minus 3a minus 4c, z equals to c minus 2b plus a, show that x plus y plus z equals to 3 multiplied by a plus 2b plus 2c. So my dear students, in here left side and right side we have to make them equal, then we can get the solution. Let us see the solution, my dear. So left hand side, my dear, x plus y plus z, and if we put down the value of x, that is 5a plus 7b plus 9c, and y, that is b minus 3a minus 4c, and z, that is c minus 2b plus a, then with the same variable, that is 5a, 3a and a, if we make them addition and subtraction, we will get 3a, because plus and minus, that would be minus, we will get 2a, plus a, that would be plus, so we will get 3a. Now 7b plus b, that would be 8b, minus 2b, that would be minus, that's why it would be 6b, and the sign will be the bigger number sign, and the bigger number is 8b, that would be plus. Again 9c minus 4c, that would be minus, so we will get 5c, 5c plus a, that would be 6c. So my dear students, if we take common, that is 3 from every term, we will get a plus 2b plus 2c, and that is the right side, my dear students. You can see 3 multiplied by a plus 2b plus 2c. So we can say right hand side equals to, and left hand side equals to right hand side, that is showed, my dear students. Now at the end of this lesson you will be able to explain supplementary angle, explain vertically opposite angle, understand the theorem number 2 and solve problem number 4 from exercise 6.1. At first, supplementary angle. Let us see the figure, that is AOB and C. And this is the definition, my dear. If the sum of the measurement of two adjacent angle is 180 degree, then the angles are called supplementary angles to each other. Adjacent angle means that is side beside. These two angles are beside each other. So these are the adjacent angle, and if we make them sum of the measurement of two adjacent angle, that is 180 degree, then the angles are called supplementary angles to each other. In diagram, angle AOC and angle BOC are supplementary angles. So my dear students, this is the supplementary angle as you can see from the figure, and it is clear to you, I think. Now, vertically opposite angle, and this is the figure my dear students. AOB and COD, as you can see, AB and CD, they are two lines, they intersect at point O. So this is the definition. The angle produced by the two opposite rays of the sides of an angle is called vertically opposite angle. As you can see, angle produced in here by the two opposite rays in the sides of an angle is called vertically opposite angle. Now in diagram, angle AOC and angle BOD are vertically opposite angles. So this is the definition of vertically opposite angle, and this is the diagram. Now theorem number 2, that is when two straight lines intersects, the vertically opposite angles are equal. So let us show me a figure that on the base of this theorem number 2 proposition. And this is the figure my dear students. You can see AC and BD, they are two straight lines intersect at point O. So the vertically opposite angles in here, it is created, that is totally 4 angles, and the vertically opposite angles are equal. So particular enunciation my dear, let AB and CD be two straight lines which intersect at point O. As a result, the angles angle AOD and angle COD and angle BOC and angle AOB are formed. That is the 4 angles my dear. We have to prove that angle AOD equals to angle BOC because these two angles are vertically opposite angles. And angle COD equals to angle AOB, we have to prove that these two angles are vertically opposite angles. So let us start the proof my dear students. So this is the proof. Now the ray OA meets the line BD at point O. You can see OA meets the line BD at point O. So my dear students, we can write angle AOB plus angle AOD equals to one straight angle. As you can see, they are beside each other, angle AOB and angle AOD. So this is the straight angle my dear, one straight angle, and we know the value of one straight angle, that is 180 degree, and instead of 180 degree we can write down two right angle, because one right angle, that is 90 degree, and two right angle means 2 multiplied by 90, that would be 180 degree. So again my dear students, similarly the ray OD, as you can see, OD meets the line AC at point O. So in here we also can write the same thing. So angle AOD and angle COD, that is one straight angle, equals to two right angle. You know, one straight angle is 180 degree, and instead of 180 degree we can write down two right angle. So this is the thing my dear students. In here you can get angle AOB plus angle AOD equals to two right angle, and again angle AOD plus angle COD equals to two right angle. So these two right angle are common, so we can easily write down, thus angle AOB plus angle AOD equals to angle AOD plus angle COD, because both the values are same, that is two right angle. So we can write down these two angles of sum, they are equal to each other. Now As you can see, in both sides, angle AOD and angle AOD, that is left side and right hand side, that is available. So we can omitting the angle AOD from both sides. And we can write down angle AOB equals to angle COD, that is the rest of the thing. So as angle AOD in both sides, that's why we can omit angle AOD from both sides. Now, similarly, we can prove that angle COB equals to angle AOD by the same way that we have proved the earlier one, that is angle AOB equals to angle COD. So this is the theorem number 2, my dear students. So particular enunciation, AB and CD be two straight lines which intersect at point O. So as a result, there are four angles have been created, and we have to prove that angle AOD equals to angle BOC, that is they are the vertically opposite angle, and angle COD and angle AOB, that is the vertically opposite angle. So in order to prove this theorem, the ray OA meets the line BD at O, and you know the one straight angle, that is 180 degree. We can write down the sum of this angle. Again, another ray, that is OD, meet at line AC at O, so we can write down the other two sum of the angle, that is 2 right angle. And these two right angles are same, so we can write down angle AOB plus angle AOD equals to angle AOD plus angle COD. And from both sides we can omit angle AOD, and we can get angle AOB equals to angle COD. So similarly, we can prove that the same thing of the other two angle COB equals to angle AOD. Now, my dear students, from exercise 6.1, one of the most important theorem, that is prove that the bisectors of the vertically opposite angles is a straight line. Now, from the proposition, we can draw the figure. That is, the bisectors of the vertically opposite angles is a straight line. So, this is the figure, my dear students. AD and BC, these are the two straight lines, and the bisector, that is OE and OF of angle AOB and angle COD, both are the vertically opposite angle, and we can bisect it. So, this is the particular enunciation, my dear. Suppose OE and OF are the bisector of angle AOB and angle COD respectively. It is required to prove that OE and OF are on the same straight line. So, OE and OF are the bisector of angle AOB and angle COD because they are vertically opposite angle, and this is the proof, my dear. OE and OF are on the same straight line. So this is the proof. We can start angle COD. As you can see, angle COD equals to angle AOB because both these angles are vertically opposite angles. Now, or half angle COD equals to half angle AOB because we can multiply both the side with half. This is the rules of the equation, my dear. If we multiply or divide or addition or subtraction in any side, we have to do the same thing in the other side also. So if we multiply with 1 by 2 in the left side, we have to multiply with 1 by 2 in the right side also. So that's why we have multiplied like this: half angle COD equals to half angle AOB, because here we just bisect these two angles. If we can take half, we can get the another thing that is very important or helpful for solving this problem. So instead of half angle COD, we can write down angle COF, and instead of half angle AOB, we can write down angle BOE. OE and OF are the bisector of angle AOB and angle COD respectively. So my dear students, from the figure, now we can write down, as you can see, angle COF plus angle DOF plus angle BOD. If you can see the figure properly, there is a straight angle, it has been created. So in case of a straight angle, we can write down two right angle. So we can write down these three angles, sum of the three angles, we can write down two right angles. Now instead of angle COF, we can write down angle BOE, because just earlier we have showed you that angle COF equals to angle BOE. So instead of angle COF, we can write down angle BOE. And another two angle that will be the same at angle DOF and angle BOD equals to two right angle. Now you can see, my dear, these three angles, they are all the angles related with angle EOF, straight lines, or OE and OF rays. As you can see, these three angles, that is the sum of them, that is two right angle, that means one straight angle. So angle EOF, we can write down two right angle, because if we divide this angle EOF, we can get the three angles, that is angle BOE and angle DOF and angle BOD. So instead of this three sum of the three angle, we can write down angle EOF equals to two right angles equals to one straight angle. Therefore OE and OF are on the same straight line, because in here one straight angle has been created. So the bisector of angle AOB and angle COD lies on the same straight line. So my dear students, this is the proof of exercise 6.1 number 4 problem. Now summary of today's lesson. If the sum of the measurement of two adjacent angles is 180 degree, then the angles are called supplementary angles to each other. Already we have learned about this topic in the first of this class. And the angle produced by the two opposite rays of the sides of an angle is called vertically opposite angle. Already we have discussed. We have solved theorem number 2. We have solved one problem from exercise that is very important for examination. So my dear students, this is the summary of today's lesson. If the sum of the measurement of two adjacent angles is 180 degree, then the angles are called supplementary angles to each other. And the angle produced by the two opposite rays of the sides of an angle is called vertically opposite angle. After that, we have solved theorem number 2. And lastly, we have solved one problem from exercise that is very important for exam. And this is the summary of today's lesson. Now, from exercise 6.1, page number 132, you have to practice problem number 5. Now there will be no SW, that's why we are giving you for practice session.